Hey guys, today we are looking at 3.1, which is all about solving quadratic equations. This section should be entirely a review from Algebra 1. There aren't any new topics. It's just refreshing our memory on how we can solve quadratic equations. So our first method in our first box here for solving a quadratic is to solve by graphing. Now this I'm not going to actually show you in here because if we're going to solve by graphing, I'm going to suggest that if you're going to choose that method, you're going to be using Desmos. So if you're going to go through and solve our quadratic equations by graphing, remember the way that we do that, we would get our quadratic equation set equal to 0, and then whatever is on that other side of my equation, if I graph that, as I usually would, which you could do by hand using any of the methods we looked at last chapter, whether that's standard form, vertex form, or intercepts form, if we graph that, the x-intercepts of that graph are the solutions to this equation. So in number 1, x squared minus x minus 6, if you were to graph that, because it's already set equal to 0, you would just go to Desmos, you would graph x squared minus x minus 6 on Desmos, or you would just graph that on paper, and you should get that your two x-intercepts happen at -2 and +3. So I'm not going to show you that. I just want to address that. If you're asked to solve by graphing, hop on Desmos, which again, desmos.com/calculator is the graphing tool. Or I think in most phones now, you can just say, hey Siri, or okay Google, graph, not actually do that, graph this equation. And actually probably could graph it for you, which is awesome. Use your technology tools for sure. With number 2, we just have one extra step before we can do that, because remember we have to have our equation set equal to 0 before we can graph it. So here the only extra step we have to do is subtract 4x from both sides, so that this is -2x squared minus 4x minus 2 equals 0, and then we would graph that. This one in particular, if I graph it, we actually end up with a single solution. My vertex happens at the x-axis. And that x value is -1. Okay, method 2, which box 2, is going to be solving using square roots. This one I really enjoy, just personally. It just seems the easiest to me, but we only have certain scenarios where we're able to solve using this method. Because in order to be able to solve using square roots, and only square roots, not factoring, the only variable term that can be in our equation is x squared, or y squared, whatever my variable is. So in this case, if you have x squared and x's, this is not going to work. But if you have any equations that are just x squared, then you can solve using square roots. And to solve using square roots, we're just going to get our x value by itself. So our x squared by itself in this case. So to do that here, I'm going to start by adding 275 on both sides. That gives me 4x squared equals 324. And then to get my x squared by itself, divide by 4 on both sides. That gives us x squared equals 81. And then our last step to get our x by itself instead of just x squared, we're going to square root both sides. And remember, when you do that in an equation, you've got that plus or minus in there as well. So positive or -9, if I plug that back into my original equation, would give me a true equation. It would work. It's a solution. So plus or minus 9 is my solution there. For number 4, same idea here. If I subtract 9 on both sides to get my x squared by itself, we end up with 3x squared equals -9. So then when I divide by 3 on both sides, I get x squared equals -3. I square root both sides, and x gives me, I can't do that, right? We've got a negative number underneath my square root. That would be, in this case, not that. It would actually be no real solution, NRS. No real solution. Which, later in this chapter, get excited, because we'll find out what we mean by no real solution, because we will come up with some non-real answers to that problem, which is fun and interesting. That's what complex numbers are. That's the second part of this chapter. We're going to do some imaginary numbers. Ooh, exciting. All right, moving along. Box 3. And these are kind of more normal methods. Here, solve by factoring. If we're trying to solve by factoring, we have to get, once again, our x squared on one side, set it equal to 0, factor that one side, and then we can do zero product property, ZPP, to solve for each of those individual things. So here I'm going to start by getting everything on one side. So I'm going to subtract 45 on both sides. X squared minus 4x minus 45 equals 0. And now I've got to factor that left side. So here I can use regular old school two parenthesis factoring because this is just x squared. I don't have to use Xbox factoring. So here I'm looking for what two numbers multiply together to give me negative 45, but add up to a negative 4, which in this case, negative 9 times a positive 5 would give me negative 45, but negative 9 plus 5 would be negative 4. From here, zero product property tells me that if I have two things that multiply together to be 0, one or both of those things have to be 0, right? Because anything times 0 is just 0. So if I have a solution of 0, that means one or both of those things were 0. So the way that we'll utilize that, we'll set each of these equations separately equal to 0. So here either x minus 9 could be 0 or x plus 5 could be 0. So then I just solve each of those for my two solutions, add 9 on both sides to get my first solution of positive 9. I subtract 5 from both sides to get another solution of negative 5. And those are my two answers. If I plugged either of those two x values into my original equation, it would make my equation true. With number 6, first thing we should check for, if we have a leading coefficient, we have something, an a value that's not just 1, first thing we should check for is a GCF to see if I can simplify this down a little bit. Unfortunately, negative 11 is not even, so I can't factor out that 2. So now I have to go to Xbox factoring. So again, for Xbox factoring, our x and our that's not going to be enough room there. We'll just start with our x. So our x of Xbox factoring, the top of my x is my first term times my last term. So 2 times 12 is 24. The bottom is my middle term, so negative 11. I'm trying to figure out what two numbers multiply together to give me a positive 24, but add up to a negative 11, which the only way that that's going to be possible is if both of them are negative, because a negative times a negative would be a positive number, but a negative plus a negative number would be a bigger negative. So really you're just looking at what two factors add up to 11 that multiply to get 24, which in this case would be 8 and 3. So negative 8 and negative 3 multiply to give me 24, but add up to negative 11. So now I can go ahead and make my box. In here, my first term and my last term are always in my top left and bottom right corner respectively. And then my negative 8x and my negative 3x are in my other two parts there. So then working backwards, either this left column or the top row, looking at a GCF. Here, my top row, I can see they're both multiples of 2, and they both have an x value, so 2x makes this just x, because 2x times x would be x squared. That tells me that this has to be a negative 3, because x times negative 3 would be negative 3x. This has to be a negative 4, because negative 2 times negative 4 gives me negative 8, or negative 3 times negative 4 gives me a positive 12. So that tells me, in this case, that this factors out into 2x minus 3 times x minus 4, and that's still set equal to 0. And now that we have two parentheses, just like we did before, we're just going to set each of these two parentheses equal to 0 to solve for x. So 2x minus 3 equals 0, x minus 4 equals 0. We'll do the easy one first by adding 4 on both sides. Our first solution is positive 4. Over here, if I add 3 on both sides, 2x equals 3. I divide by 2, and I get 3 over 2, or 1.5. If you want to put it as a decimal instead of a fraction, if that's what floats your boat and makes you happy, then that's fine with me. So positive 1/2, or sorry, positive 1.5 and positive 4 are my two solutions for number 6. All right, last one, and it's my favorite, he said sarcastically. I do enjoy quadratic formula. I really enjoy showing where it comes from, so if anyone's intrigued to see, again, the proof for where quadratic formula comes from for how we can use that to solve a generic equation. But in general, remember, if it's something that's not factorable, in order to be able to solve that equation, I have to use quadratic formula, which, once again, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a, and that is, in the generic form, ax squared plus bx plus c equals 0. So that's where the a, b, and c come from. A is always attached to your x squared term, b is always attached to x, c is always the number all by itself. So here, a is 3, b is negative 15, and c is positive 2. So if I go ahead and plug that into my formula, x equals negative b, so negative 15, plus or minus the square root of negative 15 squared minus 4 times a times c, so 4 times 3 times 2, and that's all over 2a, so 2 times 3. From here, it really just becomes a simplification process, just an order of operations problem. So as I continue down, negative 15, I'm just going to write as 15 plus or minus the square root of negative 15 squared is 225. 4 times 3 is 12, times 2 is 24, so minus 24. And that is all over 2 times 3 is 6. So here, 15 plus or minus the square root of 201 all over 6. If I was okay leaving it in radical form, you could actually stop there. That is technically a single number, or sorry, 2 numbers. But if I'm asking you to solve it 95% of the time, I want you to do it as a decimal answer rounded to 2 decimal places. So the way that we'll do this, I'll go ahead over here, and actually maybe I'll write the next step here first. Since we're doing a decimal approximation, it'll be easier to find the square root of 201 first. So 15 plus or minus, it's 14.18 is what the square root of 201 is. That, just use a calculator, square root of 201, rounded to 2 decimal places, 14.18. Now, I'm going to split this off, and where my 2 solutions come from is this plus or minus symbol. So once I'm going to do 15 plus 14.18 over 6. That's going to be my first solution, which in that case, 15 plus 14.18 is 29.18. Divide that by 6, and we get 4.86. The other one, we do 15 minus the 14.18 all over 6. And that, again, use a calculator. We get 0.14. And those are my 2 solutions. 4.86, 0.14. Okay, that's all I got for you guys today. That's solving equations that are quadratic using graphing, square root method, factoring, and quadratic formula. So if you have any questions, concerns, thoughts, or ideas, as always, make sure you guys are reaching out and letting me know. Ask away. I'd rather have you ask too many questions than not enough questions. But you guys just got to make sure that you guys are reaching out and asking for help when you need it. It's okay to need help. It is not okay to ignore it, because it's not going to go away. Trust me, it's not going to go away. All right, guys, have a good one. We'll see you soon.